Hello all, welcome back to the tutorial of C programming for beginners. Hi, this is Sakthi Arun, a M.Tech student from Unary Patna. I am technically supporting the missile Ingeniator. So far, I have given basic examples of some of the operators in C. Today, I am going to explain you guys with the logical operators in C. So what are the logical operators present in C, how they are functional inside the C program, okay? So the first thing I'm going to explain is an exclamatory. This exclamatory actually basically represents it's a logical not. Okay, so logical not. Okay, the first thing is logical not, and the next thing is logical and the next thing is logical or. Okay, so these are the three operators. It's present in the logical operators. Okay, so the first one is an unary operator. Okay, unary operator. So what are the type of operators present based upon number of operands? I have explained in one of the lecture videos. So whomever missed, just go back and watch the lecture and come back here. Okay, so unary operators is basically operates only on a single operands. Okay, and here these both are binary operands. That's because when you use two operands, say A and B, you find logical and in between the two operands. Okay, so you use this operators, and to find OR operation you use this operator. Okay, so these three operators whatever present here, it's basically working on a truth table based. So the two tables are these are the two tables present for and this is for OR and this is for not. Okay, so basically these operands are here considered as an evaluated a single entity here. Okay, so that's because if you see here the example of truth table here, so in for an AND operation, and whenever case is say I declare two variable A and B. Okay, say A is also 0, the false represents as a 0, so the A is 0 and B is also 0, then we get the result as 0. Okay, and here if A is 0 and B is 1, then also we get the result as false. Okay, and the next thing is if say A is 1 and B is 0, then we get the result as 0. Okay, that's because in an AND operation, when you have 0 in one side and 1 or 0 in other side, it results in a 0. Okay, so to get an true operations, we have to have true in both the cases. Say A is also equal to 1 and B also should be equal to 1. Okay, then only we can say we can get the value of result as 1. Okay, so this is what AND operation. But whereas in case on OR operations, we can find here say A is equal to 0, A is false and B is also false, then you get the result as false. Okay, so which means that when A is 0 and B is 0, then the result is 0. Okay, in all the other three cases, okay, we get the result as true. That's because in an OR operation, when you say when we have one variable as 0 and another is 1, then the logical operation between both of these operands is actually 1. Okay, so this is what OR operations. See here the value of A is 0 but the B is 1, so the result is 1. Whereas in case of here the A is 1 and B is 0, okay, then the result is true. In both the case of A equal to 1 and B equal to 1, that time also we get the result as true. Okay, which means that 1 1, when we have the operation between these things, the bit operation, we get the result as 1. Okay, so for a next thing is an not operation. Okay, for not operation, say we have 0, then for the result will be getting 1. If it is a 1, then we'll be getting as 0. Okay, so this is what a not operation. So here if you find if the operand value is 0, then we get the true result. Okay, whereas in case if the operand true, then we get the result as false. Okay, so the next thing is Okay, let us find some of the rules for logical evaluation. Okay, say if an operand is non-zero value, then basically it is considered as a true, which means that here the result are evaluated as a boolean values 1 or 0. Okay, so if the value is need to be evaluated as a true, then we have to say it is a non-zero value. If it is a false, then you say it's a 0. Okay, which means that you say 1, 2, 3 or 4 or 5, anything, any values, we can say it's a 1, but only if it is a 0, then you consider evaluated as a 0 value. Okay, so that what mentioned here. If the logic, and if you have any logical value, say a ampersand b, this result is evaluated to true, then the result of the boolean is 1, whereas in case of false result, then that is evaluated to 0. Okay, so that what this point mentioned here. If the logic is evaluated true, then the result yield as a 1. If it is evaluated to false, then the value is 0. Okay, so the next thing is so these type of operations are basically evaluated from left to right. Okay, so that's because when we move from left to right here, okay, let me give an example with the example. Let me explain you. So I'm taking the first example here, which is an, which is equal to a ampersand b, okay, and plus ampersand c plus. Okay, so this is what I have taken as an example. So in this case, we have to first evaluate it from the left side. So we have to evaluate this value, which is nothing but a ampersand b. Okay, so b plus. Okay, so in this case, say if the value of a is 0. Okay, so if I do ampersand and logical operation with the b plus, whereas if you find here, if the result of a is 0, okay, if I declare initially, if I initialize the value of a equal to 10, sorry, in the 0 in the beginning case, okay, then in that time, if value of a is 0, so if you are and operating with any of the operands, okay, it's not necessary to evaluate with another operand. That's because if any one of the value is 0 in AND operations, then the result is evaluated to 0. Okay, which we find here. If you find here, if the value is false, okay, false. Okay, in that case, either the second operand is true or false. That not necessary. That because the result is evaluated to 0 in the AND operations. Okay, so that's why if you find in this example, if I say that a ampersand with the b plus, if a is 0, then this whole result is evaluated to 0. Okay, if the whole result, if this is evaluated to 0, then if you are evaluating 0 with ampersand c plus, okay, if you are trying to evaluate the c plus, then also you get the result as 0. Okay, so this is what logical AND operations. In case of an worst case, if I take the next example, so if I try to evaluate the first expression like a ampersand b plus, say if a has some other positive value, non-zero value, for an easy understanding, I'm taking a as a 1. So 1 ampersand b plus. Okay, so here if as this is a non-zero value, so you can start evaluating with the b plus. Okay, say if b initially if I assign the value of b is -1, okay, so plus will represent the value to be incremented, -1 plus 1, which is equal to 0. Okay, so if this becomes 0, then the whole operation of this is also equal to 0, and the next value is 0 ampersand with the c plus is 0 ampersand c plus, this also evaluated to 0. Okay, so to get the positive to get the logical operation value as 1, you have to have we have to evaluate all the value to be true for an AND operations. Okay, for that we have to say if a ampersand b plus, so this also has to be non-zero value as 1, and this also non-zero value as 1, or any non-zero value. So when you're doing an AND operation between them, you get the value as 1. The next case, this one is evaluated with the c plus. Okay, so in this case also the c plus should be value as 1, then only the overall operation value we get as a 1. Okay, so in such a case the value 1 is assigned to an variable. Okay, so this is what an AND operation. The next example I'm going to explain is an OR operations. So here in this OR operations, what happens is, say if you are evaluating a ampersand ampersand b plus plus, okay. So in this case, the next if you find here in the last evaluation value, we have an OR operator here, okay. So here if you are finding the a of value is 0, so the operation is not ending here. That's because though this is 0, okay, you can evaluate the b plus plus, okay. If b plus plus is 1, okay, if you're finding here, if you are evaluating 0 ampersand ampersand 1, then you can say that this whole operation is 0, okay. That's because if you are evaluating 0 to a, then which means that this whole value is 0, which I have explained just before for an AND operations, okay. Though this is 0, you need not want to stop the evaluation process. That because there is an OR operations here. In OR operations, if either one of the operand has a positive non-zero value, okay, then we can find it if it is a non-zero value, then you can say that value is actually yield 1 as a result, okay. Because if I say C plus plus here, okay, so 0 OR operation with the C plus plus, then in this case if C plus plus value is 1, so 0 or with 1, the value is 1, okay. So how this is attained? Let me go back to the truth table here. You can find here that in the OR operations, if either one of the result is true, okay, say let me take here or this example, if either one of the operand is true, okay, then you not want to, okay, let me give here also, okay. So here, so if any one of the operand is true here, then you get the value as true, okay. So this is what mentioned I'm trying to explain in these examples also, okay. So when you say that 0 with C plus plus, then you can say you have to evaluate till C plus plus. If it is 1, then the value is equal to 1, okay. So whereas if it is in if I say that a ampersand ampersand b plus plus, okay, so if this both value is non-zero value, then the result is evaluated to 1, then you need not want to bother about C plus plus. That's because if any one of the operand is 1, then you can say the result is 1, okay. Okay, so in my next lecture video, I will give the best example for understanding all these operators. Okay, so if you have any doubt or comment, please post in the comment section. Thank you all for watching this video.